Hey guys, it's Mr. Walker here, and welcome to another math lesson. So, in previous math lessons in this module, we've been diving into fractions a little bit, right? Looking at equivalent fractions and how we can make equivalent fractions and what that looks like when we add or kind of like combine some equivalent fractions. And all that's been working out well and good. But today we're going to move on to the concept of adding fractions, okay? And not just equivalent fractions, but we're going to be taking a look at fractions that don't have the same denominator, that aren't split into the same amount of parts. Okay, so we're going to take a look at how we can add these fractions and what that actually means when we are adding the fractions. Right, and so when I started to think about this lesson today and adding fractions with unlike denominators, I wanted to think of an analogy to kind of like relate it to the real world, right? So you don't know what an analogy is? All right, cue the music. Wait a minute. This isn't ELA. This isn't a math vocabulary term. This is an ELA term. That's okay. Regardless, I wanted to make an analogy. And an analogy is when you compare two things that might not be alike. You compare them to help make sense of what they are, right? So, for example, Mary had a little lamb. Its fleece was white as snow. Now, I might not know what fleece is, but I know what snow is, and I know what color snow is, and I can kind of make that comparison. I can say, okay, well, her fleece, her fur, must have been as white as snow, must have been that color, right? So I can use that analogy to help me like understand things better. So I like to do that in math a lot, right? Relate it to the real world. How can this make sense to me? So I came up with this. So hang in there with me with this. I have some balls of Play-Doh here, okay? So Play-Doh, what does this have to do with math? What does it have to do with adding fractions, right? Well, I thought of it this way, right? If we're adding fractions that have the same denominator. It's like adding together two balls of the same color Play-Doh. Okay, we can combine those together real quick, and we're basically just going to get more of the same thing, right? More of the same thing. If we're adding fractions with unlike denominators, we're still adding basically the same thing. It's still Play-Doh, right? But it's two different colors now. And we have to get those colors the same to add them together. So for here, I'm trying to add this blue to this yellow, and they're not the same color, so they're not gonna really like go together, right? I mean, they will, but you're gonna get like a jumbled mess. But if I add a little bit of the yellow to the blue, a little bit of blue to this yellow, what I'm actually gonna get, what's gonna happen is they're both gonna turn green, right? And now that they're both green, I can add those together. And if I add them together, I'm just going to get a bigger ball of green. So, well, what does this have to do with fractions? Well, like I said, if I have two fractions that have the same denominator, 1/3 and 1/3, they're the same color. I can mix them together and I will get more of the same color. If I have two fractions that aren't the same, that don't have the same denominator, it's like they're different colors. Okay, so I can't mix them together. I'm going to have to change them before I can mix them together to get more of the same color. Like I did, I had to add blue to this guy, yellow to this guy, which turned them both green. And then we can mix them together to make one green. I know that's not the greatest analogy. I know this isn't the greatest example, but at least kind of gives you an idea of what we're going to be doing here and why we need to change these numbers in order to get them to work, in order to be able to add them together. We're going to have to get them on the same page so we don't make a mess of things, okay? So that's the goal for today. So what you're going to need is you're going to need plenty of Play-Doh, and you're going to need some mixing bowls, and you're going to need, just joking, really all you need is something to write on, something to write with, and just be ready to kind of manipulate and play with these fractions, okay? So when you have those things gathered up and you're ready to go, click continue and we'll get working. Alright, so we're going to start here by taking a look at an example. We're going to try to actually add two fractions together, okay? And these fractions are going to have denominators that aren't the same. So if I wanted to add 1/2 and 1/4, the way it is right now, I couldn't add them together. They're like two different colors. Our denominators are not the same, so they're not going to go together. So what I'm going to have to do is I'm going to have to find some units that they have in common, try to get them to the same number, and then I can add them together, okay? So here's how I'm going to do that. In previous lessons, we learned how to represent fractions using rectangles and squares and different things like that. So I'm actually going to draw this out to kind of visually represent like what's happening here. All right, so let me go ahead and draw in some squares here. So draw one square here to represent my 1/2. And actually what I'm going to do is I'm just going to copy this square So I have the same size squares for each of my fractions, even though I'm going to kind of split them up differently. Okay? So for my 1/2, I'm going to divide it into how many parts? How many parts am I going to divide this into? Right, 2 parts, right? So I'm going to draw a line vertically to divide this into the 2 parts. Okay, so I'm just going to draw a line straight down the middle here. Okay, so now I have my 2 parts, and how many of those parts am I going to color in? Like, what's my fraction? 1, right? 1/2, one of those 2 parts. Let me go ahead and color that in. Nice orange color, beautiful. Okay, cool. So for my second guy over here, I have 1/4. So how many parts am I dividing this rectangle into? 4, right? So this one I'm going to draw my lines horizontally. So here I went up and down. Here I'm going to do horizontally, and I'll show you why in a second, or how that's going to make sense. So I'm going to draw 1, 2, 3, 4. 1, 2, 3, 4. So I have my 4 parts, and how many parts are colored in on this fraction? Just 1, right? Let's get a nice purple color here. Oh yeah, that's nice. Okay, cool. All right, so I have my 1/2 colored in, I have my 1/4 colored in, I have both of my fractions represented, okay? And just to kind of clarify this a little bit more, I'm going to draw a bracket here because this represents one whole, right? My whole rectangle represents one whole. And then the part that I colored in right down here, that represents, of course, 1/2, right? Over here, the same thing, still representing one whole with the whole triangle. Whole triangle, holy cow, what am I, a kindergartner? The whole rectangle, and then this part right here, it represents 1/4, okay? So right now, we still can't add these fractions. They're not the same pieces. They're not going to go together. It's like those 2 different colors of Play-Doh. It's just not going to work. So what we're actually going to do, like we did with the Play-Doh, is I'm going to add a little bit of one fraction to the other fraction, and a little bit of the other fraction to that fraction. We're going to kind of combine them a little bit, and then we can mix them together into one new fraction. Okay? And here's what I mean by that. So you see that I drew my lines differently on each fraction, right? I drew this one vertically and these horizontally. And the reason is I'm going to mix these two now, and we're going to see what happens. So if I take my half and I bring it over here, okay, now I have split my fourth, my rectangle that was divided into fourths before, I have now split it in half. So now I have eighths, right? I have 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces, okay? I'm going to do the same thing to my other fraction. I'm going to drag over my fourths to my 1/2, and would you look at that? 1, 2, 3, 4, 5, 6, 7, 8 pieces. So now my fractions have changed. We've mixed them up a little bit. They've changed. Our denominators are going to be different. Our overall fractions are going to be different. Same amount. My part that I colored in, that hasn't changed at all in either fraction, right? But the fraction itself is going to change. The amount of parts is going to change. So if I look at this now, I have 1, 2, 3, 4, 5, 6, 7, 8 parts. And how many of those parts are colored in? 4. 1, 2, 3, 4. 4 parts. So I made an equivalent fraction. 1/2 and 4/8, that's an equivalent fraction. Over here I have 1, 2, 3, 4, 5, 6, 7, 8. 8 parts still. And how many of those parts are colored in? 2. 2/8. Again, I made another equivalent fraction. That 1/4 and 2/8, that's the same amount. I just used different parts, different amounts of parts. So now my two fractions look like this. I have 4/8 and I have 2/8. My denominators are the same. So I can now add these two together. So 4/8 plus 2/8, let me just rewrite it up here. 4/8 plus 2/8, that's going to give me 6/8. Cool? All right, awesome. So with this, I'm sorry, my 8s didn't really look like 8s here. So I have my 6/8. So I got my answer. I was able to combine it. If I wanted to take this a step further, which I recommend that everybody does, let's think of it this way for a second. If I combine these two, right, I'm just going to bring these two over here and draw them all in the same rectangle so we can kind of see like what it looks like and what it represents. So let me just bring these two guys over here. Okay, so again, now we have 6/8. 1, 2, 3, 4, 5, 6. 6/8. But what if I kind of rearrange this a little bit? And let's say I take this eighth from here and add it in over here. And now instead of looking at this as eighths, let's look at it again as fourths. 1/4, 2/4, 3/4. Actually, 6/8 and 3/4, those are equivalent fractions, okay? So I can make this bigger pieces, basically. Same amount, just bigger pieces. What we call that like reducing the fraction, right? Getting it in its simplest form. Because as we learned before, if we multiplied 3/4, if we multiplied it by the same number, times 2 and times 2, that would give us 6/8, which is what we had here. Okay. If we divide a fraction by the same number from the numerator and the denominator, we'll get an equivalent fraction as well. So we can multiply to make the numbers bigger. We can divide to make them smaller. So 6 divided by 2 is 3. 8 divided by 2 is 4. 3/4, which is what we have here. I just kind of visually represented it over here. Same difference, okay? Let's try like one more example. All right, let's say I had 2/5 and 2/3. All right, so if I wanted to add up these two fractions, if I look right away, well, my numerators are the same. That doesn't mean I can add them. My denominators have to be the same. I have to be talking about the same amount of parts, right? Same amount of total parts. So I'm going to draw two rectangles again to kind of represent this visually. And my first fraction, I'm going to split this rectangle into 5 parts. Okay, so let's see. 1, 2, 3, 4, 5. Cool. I'm going to split this guy into 3 parts, to thirds. So 1, 2, 3. Okay, cool there. Now I'm going to come back and I'm going to color in the parts that I have. All right, so let me go ahead and color in my fractions now. So I have 2/5. So if I color it in here, this would be 1/5. This would be 2/5. Okay, cool. Let's come over here. Let's do red this time. And we'll do 2/3. So there's 1/3. And there's 2/3. We're good to go. And just to kind of emphasize the point, I'm going to label these again. We started out, this is 1 whole. Okay. This is 1 whole. And what I colored in over here, this is 2/5. And what I colored in over here, this is 2/3. And again, I did one of them vertically, right, up and down. Did my first one up and down, did my second one across. Okay, it doesn't matter which way you do it, as long as they're different. That way we can overlay them and do a comparison. Okay, so now if I were to take my thirds, bring it over here to my fifths, okay, and if I were to take my fifths and bring them over to my thirds, there we go. Excellent. So now, if I count them up, I can count up, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here, now this is switched out of 15. And I have 1, 2, 3, 4, 5, 6 out of 15. Over here, I'm going to have 15 as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 15. Cool. So I have those equivalent fractions now. So now I can add them up. 6/15 and 10/15. Let's do this up here. 6/15, 10/15. I have those denominators, which are the same amount of parts. So 6 plus 10 will give me 16/15, because my amount of total parts isn't going to change. I would still have 15, right? That's what we divided it into. That's what our denominator changed to. That's going to stay the same. So that's awesome. So if I had 16/15, that's interesting. So I have more than a whole, right? If I were to move these over, all these shaded pieces in here, 10 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh, I'm full. So it would be 10. One more 15th out here. So I would have 1 whole and 1 15th. 1 whole and 1 15th. Hopefully that starts to make a little sense. It's something kind of we did in the last lesson as well. So hopefully this is starting to click and make more sense. You guys are going to practice with this a little bit today. If you have any questions, comments, or concerns about what we're doing here, how we're using these visuals to kind of make some equivalent fractions, please reach out and let me know. I know there's other methods to do this, obviously, and we're going to get to them, but I wanted to show you guys, start with the visual representation of why this is working the way it is, and then we'll step into how we can do it numerically as well. So thank you guys for watching. Let me know if you need anything else, and we'll talk to you soon.